Good morning, dear students. So we are going to discuss a very small topic in this video, that is irrational number. Already we have discussed what is rational number. We have taken different examples of rational number. Now, if we start thinking about irrational number, we'll have to go for the definition of rational number. The definition of rational number is a number which can be written in the form of p by q, where p and q are integers and q is not equal to 0, is said to be a rational number. Now, let us come to the definition of irrational number. The definition is almost same. It's almost same. Only one more word has to be added there. The word is not. Now, I am using this word in the definition of rational number. A number which cannot be represented in the form of p by q, where p and q are integers and q is not equal to 0, is said to be an irrational number. See the difference of rational number definition. In the definition of rational number, a number which can be written in the form of p by q, where q is not equal to 0, is said to be a rational number. Now, irrational number, a number which cannot be represented in the form of p by q, where q is not equal to 0, is said to be an irrational number. So that means obviously we can say that the number which are not rational are said to be irrational. Now come to let us think about the number which are rational. Like, say, let me take integer. 1 is a rational number, 1 is a rational number, 2 is a rational number, 3 is also a rational number, 4 is a rational number. Okay, out of them, let me start with 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, all these. You can say I have written natural number here, 10 and dot. Okay, all these are rational number. Now if I take the square root of all these number, means here square root of 1, how will you write? Square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9. Okay, and so on. Square root of 10, 11, 12. Out of them, this gives you 2. Root over 4 is equal to 2. Root over 1 is equal to 1. Root over 9 is equal to 3. This we can find out. That means what? Root over 4 is 2. 2 is a rational number. 2 is a rational number. So 2 is a rational number means root over 4 is a rational number. That means this is not irrational. This is not irrational. Again, come here. Root over 9. Root over 9 is 3. 3 is rational. So root over 9 is rational. So root over 9 is rational means it is not irrational. This is not irrational. Again, come here. Root over 1 is 1. 1 is a rational number. So root over 1 is also a rational number. That means what? Root over 1 is not an irrational number. Then what is left? Root over 2, root over 3, root over 5, root over 6, root over 7, root over 8. All are irrational number. So after that, root over 10, root over 11 is irrational. Root over 12 is irrational. Root over 13 is irrational. Root over 14 is irrational. Root over 15 is irrational. But root over 16, no, it is not irrational, because root over 16 is equal to 4. So root over 16 is a rational number. Root over 17, root over 18, all these will be irrational number. That means what? Whenever we get 1 is a square number, 4 is a square number, 9 is a square number, perfect square. So square root of a perfect square is not a irrational number. That means, how can we say square root of non-perfect squares are always irrational number. So what I have said, square root of non-perfect square is always irrational number. That means what now we can say? Now we can say one example of irrational number. Number 1, it is root over 2, root over 3, root over 4, root over 5, root over 6, root over 7, root over 8. All these are irrational numbers. This is first point. Then second point is, we have already discussed in a previous video that different types of decimal we have discussed. So in different types of decimal, we got there the last type of decimal to be, can you remember? Yes, it is non-terminating, non-recurring decimal or non-terminating, non-repeating decimal. So non-terminating, non-repeating decimals are also irrational number. That means irrational number like non-terminating, non-repeating. How to write? That day I show you in that video. It was shown to you. 1 0 you write, 1 0 0 you write, 0 0 you write. All these are. This is a non-terminating, obviously, and non-repeating also. I said why it is non-repeating. Say this is, or you can write any digit, whatever you like, 2, 5, 7, 9, 1, 2, 5, dot you put. This is non-terminating also, non-repeating also. So non-terminating, non-repeating decimals are irrational number. Lastly, we discussed about pi. What is the value of pi? You will say it is 22 by 7. So pi is equal to 22 by 7, and it is 3.1415962. In that way it will go. Okay. So now I will claim that this pi is an irrational number. Then definitely you will ask me question, sir, why pi is irrational number? Because pi is equal to 22 by 7. So 22 is an integer, 7 is an integer. So we can represent them in the form of p by q. So this is also an rational number. No. The answer is no, because this is not. It is an irrational number because we write 22 by 7. This is actually approximate value of pi. Approximately, this is not exactly equal to, pi is not exactly equal to 22 by 7, but we write that is different. We use in solving problem, that is different. It is equivalent to. So pi is not exactly equal to 22 by 7. Pi is exactly equal to this one. This is actual. The value of pi is 3.14151962. In that way it will go. And if you try to get a nearest rational form, this is the nearest rational form of pi. So that is why we use pi equal to 22 by 7. So you should always consider that pi is equal to actually it is, and we represent it by 22 by 7. So pi is also an irrational number. Now, all this in real number line, you must be knowing real number line. We will discuss later on 0, 1, 2. All this we write number line in this way, -1, -2, in that way it will go. We can represent all rational number here, that we know. Similarly, we can represent all irrational number also here. All irrational number here. In fact, we can represent all real number on the number line. The name of this line is real number line, but we say it to be number line. So now comes, what is again real number? What is real? This is very new for you maybe. What is real? Real number. So real number is nothing but you get a big huge tumbler. In that tumbler you put all the rational number, you put all irrational number, put them together, check them, then you are going to get what? Real number. You are going to get real number. So that means what? All rational number and irrational number together forms what? Real number. So all real number can be represented on the real number line. Therefore, irrational number can also be represented on